When you go to another planet, there's just so much potential for making brand new discoveries. My name is Katie Stack Morgan, and I study rocks on other planets. So Mars 2020 will be seeking signs of ancient life in the rock record of Mars. The instruments are really well suited to look for things that we call biosignatures, which are signs that ancient life might have been there in the past. To really confirm that life had a hand in creating those signatures or textures, we really do need to bring those samples back. We have capabilities in laboratories here on Earth that we can't fit in a compact instrument on a rover. This is the Mars Yard, and this is where our rovers practice driving over rocky terrain. We work together with the engineers to understand what type of terrain the rover can handle so that we can get to the most exciting places, which are often the most challenging. So our landing site for Mars 2020 is Jezero Crater. What's really exciting about Jezero is that it has a beautifully preserved delta. They tend to be a really good place to preserve evidence of past life. And we look for things like organic matter that get concentrated in the rocks of a delta. So this rock is a sandstone, not unlike a rock that we might actually find in Jezero Crater. We would be interested in sampling a rock like this to understand what each individual sand grain has to tell us about Mars and its evolution. Growing up as a kid, we used to go on lots of hikes and would visit national parks for summer vacations. So when I found out that I had the opportunity to combine geology and love of the outdoors with exploring rocks on another planet, I thought, this is really the perfect type of thing for me to do. Not only could I work on an interesting science project, but I could do it with a big team of people all working together with a focused goal. And I thought, that's what I want to do.
I'm Marina Jurica with NASA's Jet Propulsion Laboratory. JPL is where the Mars 2020 mission and Perseverance rover are managed. Getting to Mars is a test of perseverance in itself. There are so many incredible stories from the thousands of people who are a part of the mission. Today, we are with one of the many faces behind the spacecraft. Mars 2020 Deputy Project Scientist Katie Stack Morgan is hoping to find the signs of ancient life on the red planet. She joins us live to answer some questions. If you have any questions, you can use the hashtag AskNASA. In light of the times, I am talking to Katie across the miles in our homes as we are social distancing. Welcome, Katie.
Thanks, Marina. I'm so glad to be here today.
Well, thank you so much for joining us. Now, what exactly does a deputy project scientist do with the Mars 2020 mission?
So the Mars 2020 team has hundreds of team members, included in that are 350 scientists, both at JPL and around the world. And as a deputy project scientist, together with the project scientist and a fellow deputy, we're the science leadership for those 350 scientists. And so during the course of the mission's development, we represent the science objectives as they're building the rover. And once we land on the surface, we lead the science team in the science mission, helping to make decisions for what we do with the rover on Mars and how we do the exciting things that we hope to do on the surface of Mars with Perseverance.
And exciting it is for sure, Katie. Now, how did you get where you are today? And what did you study in school? And what jobs led to this one?
Yeah, so in college, I knew I wanted to be a scientist. I didn't know which kind of science I wanted to go into at first. And I started in astrophysics and astronomy, and I was always interested in space. But I had the great fortune of taking a planetary geology class, so geology of other planets. And I just loved it. And so I started taking more geology classes and chemistry and math in preparation for being a planetary geologist. But I also took a lot of history classes, and I think that really contributed to my fascination with the history and the story of planets and how they evolve. And so it was a combination of that kind of background that I think really prepared me to go into a role like this. And I started off on the Mars Science Laboratory Curiosity rover mission, and had just a great time on that mission, and that continues today. And that led into this job here on the Perseverance rover team. And I'm really excited to lead this team and to do exciting things with Perseverance.
Well, like you said, rocks have a history and they tell their own story, and that's what you're going to hope to find out. Now, the rover was recently named Perseverance. What does that name mean to you personally?
I think that name was such an appropriate name for the Mars 2020 rover, which is the first step in a possible international sample return effort to bring samples from Mars back to Earth. Usually when we send spacecraft to Mars, it's one rover or one lander at a time, and that's the mission. But with Perseverance and this future sample return campaign, it's multiple missions over many years. and with international participation. And we're going to need perseverance to get those samples back here to Earth. And so I think that name is a good reminder, even though Mars 2020 is that first step of the journey that we have ahead of us and the challenges to ultimately succeed in our science objectives of bringing those samples back. And so we're looking forward to that. And the name of this rover serves as a great reminder for what we have ahead and to help keep us motivated to keep going to reach that ultimate objective.
And I know there's so many of us who just can't wait to go on this journey with you and the team, Katie. Now, Perseverance is landing on Mars at Jezero Crater. Why is it that you and the team chose this particular area?
So there are a lot of craters on Mars, and we've visited other craters on Mars with previous rovers. But Jezero is special for a couple of different reasons. For one, it's on the edge of one of the largest and oldest impact basins on the surface of Mars. And so the rocks that we have exposed in Jezero Crater really give us that window to the earliest time in Mars's history when we think life had the best chance of existing at the surface. And so that's exciting in and of itself, and the potential to bring those rocks back to Earth to study is just a fantastic potential. But Jezero is also special because we know, slam dunk, that it had water in that crater. And that's not something we necessarily know for all the craters on Mars, but it has the beautifully preserved delta and an inlet channel and an outlet channel. So we know that crater basically filled up like a bathtub at some point in the ancient past, and overflowed at some point. So what we have in Jezero Crater are these ancient rocks representing earliest Mars history. We have rocks that were deposited in an ancient lake, which we know from Earth are a great place to search for signs of life. And if things go well, we'll have an opportunity to answer some of our most fundamental questions we have about Mars history and planetary evolution, in addition to continuing our search for life on Mars and elsewhere in the solar system.
The pictures are just incredible of Jezero Crater. It's so neat to look at that. And I'm sure you're super excited to be a part of this mission. How are you going to feel next year on February 18th when it hopefully lands?
Well, I think there are a lot of nerves associated with launches and landing events. So we'll certainly I'll be on the edge of my seat. But there's nothing quite like getting that first image back from the surface of Mars, and that's an experience that I was really lucky to have as a member of the Curiosity rover team. And so I can't wait to get that first view in Jezero Crater. The past couple of years, I've spent hundreds of hours looking at these images from our orbiter cameras. So that opportunity to translate what we see from orbit to then what we see on the surface is just a great moment for me as a scientist. And so I'm really excited for that. And we have a lot of work to do on the surface, caching those samples and getting ready for Mars sample return. So I'll be ready to hit the ground running, and excited for making those scientific discoveries that we think are really going to advance Mars science and our understanding of the solar system and how it evolved.
That is going to be really awesome, Katie. And as you folks might not know at home, the launch window for Mars 2020 mission opens up July 17th, and that's down at Kennedy Space Center. And so we'll be keeping our fingers crossed for a very successful launch. Now I'd like to welcome Stephanie Smith, our social media manager, to answer all of your questions coming in for Katie. Welcome, Stephanie.
Well, I'm certainly looking out for all of those questions, but we're going to let Katie answer them. We're seeing lots of great chat. We've got people from around the world watching live right now. India, Jamaica, Germany, right here in Pasadena, home to our laboratory and our Mars rovers. Anyway, without any further ado, if you're watching this on YouTube and you don't see that chat, just go ahead and refresh your browser because the chat window is open. We'll be taking your questions from there, as well as monitoring Twitter for the hashtag AskNASA. Without any further ado, Katie, we're getting all kinds of different questions, including one about MOXIE. We know MOXIE is a technology demonstration on the rover, but Saverio would like to know, how does MOXIE work?
Yeah, so MOXIE is like a fuel cell run in reverse, and you might be familiar with that from kind of the hybrid cars we have here on Earth. But basically, what happens with MOXIE is we take CO2 from the Martian atmosphere, bring it into MOXIE, and then through electrochemical processes, we basically run electricity through the CO2 molecule and split that into the carbon and the oxygen. And by doing that process, we're able to produce oxygen, and then that goes back out into the Martian atmosphere and environment in terms of what MOXIE does. But our hope in the future, and the reason why MOXIE is a part of the Mars 2020 payload, is that we'd like to demonstrate the production of oxygen in situ on Mars for the potential for future missions to take advantage of that. In particular, human exploration mission opportunities that would need to use oxygen on the surface, either for keeping their habitable environments going, as well as producing fuel that might get astronauts from the surface of Mars back to Earth. And so we're excited about that technology demonstration and demonstrating that capability on Mars for the first time.
Fantastic. All right. Heidi on YouTube wants to know, will the rover look for water?
Yes, that's a great question, and we will indeed search for water, but it's not necessarily searching for water that is liquid on the surface of Mars today. The surface of Mars isn't capable of supporting liquid water. The pressure is too low and it's too cold. But we're looking for water in other ways, and for example, minerals, which are what rocks are made of, can actually bind water within the structure of those minerals, and so rocks can actually have water in them. And those minerals that have water are some of the most exciting minerals that we look for on the surface of Mars, because they are also really good at trapping and collecting organic matter, which is one of the key things we look for in determining habitable environments in the ancient Mars rock record and signs of life. And so we'll be looking for hydrated minerals and evidence that water was once there on the surface of Mars. And so that's the way we search for water. It's most ancient water that we're looking for, as opposed to liquid water or ice at the surface today.
Okay, so Pete over here on YouTube certainly knows a lot about this rover, and one of its new features, it will be carrying not one, but two microphones. So as a scientist, what do you expect to learn from those microphones?
Yeah, so one of those microphones is part of the SuperCam instrument suite, and so SuperCam uses a laser to shoot rocks and creates a vapor when the laser interacts with the rocks, and then the spectrometers on SuperCam will analyze that vapor. And so what we're going to have for Mars 2020 for the first time is a microphone that it basically is able to hear that zap and go zzz. And so that'll tell us perhaps about the material properties of the rocks that we are in fact analyzing with the SuperCam laser. So we're interested to know more about the interaction of the SuperCam instrument with the surface of Mars, and hope to be able to understand more about the rocks that we are analyzing with that instrument.
So Shellen on YouTube would like to know, how does all this data, all these images, these sounds, how does that data collected by the rover get transmitted back to Earth?
Yeah, so we actually use a series, our orbiters that are going around Mars. So the rover collects its data, then it transmits that data to our orbiters. Our orbiters transmit it through the Deep Space Network, and then that all comes together in mission control at JPL. And so that's how we get our data. And it's not an instant thing. It takes some time for that to happen. And our orbiters only get into a configuration where we can communicate with them at certain times of the day. But we know those ahead of time, and so we can basically plan the times when the rover basically picks up the phone to call the orbiters and send the data back to Earth.
Questions are just pouring in here. Oh my goodness, a lot of them are engineering questions. You're a project scientist. I want to try to keep this focused on science today, but I will ask something from someone whose dream job is to work on a mission like this. And it might give you a chance to talk about the diverse backgrounds of your colleagues on Mars 2020. So Le Garcia on Facebook wants to know, do you have a job there for an oil engineer? Because working with aerospace is his dream.
Yes, that's a fantastic question. One of my favorite things about working on a rover mission is the diversity of the people who who are behind the rover mission, and you'll get to hear about some of those in the coming weeks. But from a science side, we have people who consider themselves planetary scientists or planetary geologists like myself, but we also have biologists and physicists and chemists, and there's a place for everyone, because when we send these rover missions, there's so many different aspects and scientific approaches that we take to understand the data that comes back. And for people who are focused on instruments and instrumentation, of course, we need those folks as well, because we operate these instruments on Mars in unique environments. And we're also looking to understand the climate of Mars, both present and past. So atmospheric science is an important part of what we do with these Mars missions. And of course, engineers, all different types of engineering, system engineering, mechanical engineering, electrical engineering, all very important for getting a rover built and operating safely on the surface. So you mentioned, Stephanie, an oil engineer. And so this is an interesting question, because some of the strategies that the oil and gas industry uses on Earth are very similar to some of the approaches that we take when we're searching for organics on Mars. And so deltas are a place that the oil industry is very interested in the rock record here on Earth, and we're interested in them on Mars because they are a great way to concentrate organic matter. And so we use some of the same strategies that scientists have been using and geologists have been using here on Earth for decades now to search for organics on Earth, and we're using those to study organics on Mars. We also have some shared ties in terms of the way that we drill and understand drilling technology, and that's of course something that's very relevant in the oil and gas industry here on Earth. And there's some lessons learned that we've taken from that industry and applied to how we learn and develop our drills that we use to sample on Mars. So there are a lot of connections there, and I think those connections exist for a lot of different fields in science and engineering here on Earth. And there's easy translation of those skills here on Earth to studying another planet.
So Nandro in the YouTube chat wants to know how the samples that Perseverance will collect, how will they get back to Earth?
Yes, that's a fantastic question, and we're all very excited about the potential for bringing those samples back. And right now, NASA has developed an architecture that's in development and in work for how we would bring those samples back, and it involves participation from international space agencies as well. And so the concept right now involves kind of a multi-staged mission series of missions. The first of which is of course the Perseverance rover, and we collect and cache those samples. And then sometime down the road, the next leg of sample return would arrive, and we anticipate that leg will involve a small rover called a fetch rover. That's what we call it now. That would have the potential to go out and collect samples that Perseverance has put down on the surface, and it would have an ascent vehicle that would help get those samples, once delivered, back up into orbit, where it would potentially rendezvous with an orbiter that would then come back to Earth. There might be another leg there as well, orbiting Earth. And eventually we would look to get those samples back to the surface. So those details are all still in work, but what I can say is it's definitely a multi-leg mission with international participation, because this is a big effort, and I think we all it's important that we're all working together, bringing, all of our expertise in planetary exploration to bear on accomplishing the goal of sample return.
So specifically on 2020, Alex and Gunny are both wondering the same thing. What's the expected lifespan of this rover?
So it's how we determine that for Mars missions, and it's not just Perseverance, but we have a prime mission span, and so that's basically the period of time that the rover is kind of its guaranteed lifetime, and we determine that via testing. And so the guaranteed lifetime for the Perseverance rover is 1 Mars year, or about 2 Earth. As many may be familiar, previous rovers like Opportunity and Spirit and Curiosity, still on the surface today, have way outlived their prime mission, and so we are optimistic that could happen as well with Perseverance, but the guaranteed lifetime is 1 Mars year, or about 2 Earth years.
All right, scanning for more questions. They are just pouring in from around the world here. Thank you so much, everybody. So P. Otley on YouTube want to know if there is something specific with this rover that you are hoping to discover that other rovers simply weren't advanced enough to do.
Yes, that's a fantastic question, and it really gets to the core of what Mars 2020 and Perseverance are all about. And this is our search for biosignatures. So the Perseverance rover has two brand new instruments on the end of its arm that have the ability to map very fine scale textures in the rocks with very fine scale composition in the rocks. And we can create those maps and then basically overlay them on top of each other and look for very distinct patterns, both in the textures and the composition of those rocks, and distribution of organics that can give us a clue that life once had a role to play in the creation of those signatures. And previous rover missions have, of course, sampled rocks on Mars and looked for organics, but they do it in a way that basically grinds up the rocks and destroys the evidence of those textures in that sample. With Mars 2020 and Perseverance, we're able to preserve those textures, analyze them at a very fine scale, and those are exactly the techniques that we use on Earth when we're searching for signs of ancient life in our own rock record. And so I think that the Perseverance rover is the best equipped of any Mars rover to actually seek those signs of ancient life on Mars, and our payload can help support that. And so we're hoping to really make progress on that question, the question of life on Mars, and our payload is really well suited to doing that.
So let's see here. Connor on YouTube also asks, what energy source will this rover use?
Yeah, so we have a similar energy source as the Curiosity rover. It's a radio isotope thermal generator, and it's actually similar to what Mark Watney used in the Martian movie, and how he kept warm. And so we have a similar system on Perseverance, and it not only generates energy to keep the rover going, but it also, of course, generates the heat that helps to warm up the other parts of the rover so that we can operate even though it's very cold on the surface of Mars.
So we're also getting some questions about the recently named Ingenuity Helicopter, which is definitely separate from your flagship mission. It's a technology demonstration. But Katie, I know, what are you excited about the helicopter, and what might it be able to tell us?
Yeah, so the Ingenuity, newly named just yesterday, is a technology demonstration riding along with the Perseverance rover, and we'll carry it on the belly of the rover. And sometime in the first months of the mission, we'll drop Ingenuity, drive a little ways away, and it'll do a series of test flights. And this will be the first time that we're testing out a helicopter in a Mars environment, Mars atmosphere. And so we're looking to really just prove that it can work, that we can take a helicopter, even though the Mars atmospheric pressure is so much lower than here on Earth, and actually operate that kind of technology. So a small number of flights just to prove that it can go up and go down, maybe move laterally. We expect that it's going to take some images while it's up in the air, and we're very excited to get those images down. Perhaps we'll even be able to take a picture of the rover from the helicopter, and that'll be a great image, I think, for us all to see. And so we're interested in learning how this technology works on Mars, with an eye towards future Mars exploration that might take advantage of this same kind of helicopter technology that would allow us to explore, large distances on the surface of Mars with a single helicopter leap. So we're excited to see how Ingenuity operates in the Mars environment, and we're looking forward to that technology demonstration.
So you mentioned some of the challenges that the helicopter will face. What are some of the biggest challenges to designing a vehicle that can function on a foreign planet? This is from Manish on Twitter.
Yes, so one of our biggest challenges actually with the Curiosity rover that's currently exploring Gale Crater right now was its wheels. Very early on in the mission, we discovered with Curiosity that its wheels were much more wear and tear than we had originally expected. And it was about 300 days into the mission where we noticed these big gashes in the wheels. And that was a big threat to Curiosity's mission in Gale Crater. Of course, that mission is still ongoing, and we've learned how to use the wheels as a resource. But we decided when we were developing and designing the Perseverance rover that we didn't want to have to worry about that kind of issue on Mars with Perseverance. So an example of how we've kind of taken a previous challenge and adapted to it we've made the Perseverance wheels much stronger. They're a little bit heavier, but they're much more robust to the type of terrain that we expect to encounter on Mars. So we're hoping that that's actually not a challenge for us, but that's one example of the type of challenge that we can encounter. I think for us, one of our biggest challenges that we'll look to overcome, I think, is we are responsible for collecting the samples for potential sample return. So we're going to have to move expeditiously through our landing site and be efficient with our exploration, while at the same time making good science decisions about the samples we collect. And so I think we feel the responsibility, and we're excited to have that responsibility. But we know that the future generations of scientists are depending on us to put together a good sample cache. And so we take that seriously.
All right, back to the science here. Unsmart Nerd and Snom Noms over the YouTube chat have been having a conversation about the Martian blueberries that were found by the Spirit rover, the hematite. So they were wondering if you could explain what these blue pebbles were a sign of, and do you expect to find something like that with Perseverance?
Could you repeat the question?
Sure. So, can you explain this? This is going back a little bit to the Mars exploration rover Spirit, when it found the Martian blueberries or hematite pebbles. Why was that significant? In just scientifically, and what kind of discoveries do you hope that you might make with Perseverance?
Yes. So. The early part of the question was still coming in a little garbled, but I'll address the second half, which was what we're looking to discover with Perseverance. And so I mentioned biosignatures, and I think that's really a key part of what we're searching for with Mars 2020 and the Perseverance rover. So we'll be looking to explore the sediments of the ancient delta present in Jezero Crater, looking for signs of ancient life, and looking to understand the evolution of that delta over time. And deltas are exciting because they represent, we know they get deposited in standing bodies of water. And so we'll be looking to track the evolution of water in the history of ancient Mars. And so looking for evidence of mental change and places that in the rock record that we think were once habitable. And also with an eye towards collecting samples that can tell us more about the evolution of Mars as a planet, looking for diversity of geological environments, evidence of volcanism and impact processes, as well as the sedimentary processes that we know deposited the lake and delta sediments. We'll be looking for evidence of water interactions, and that might be relevant to the early part of the question that I think was referencing Spirit. So we'll be looking to understand how water moving through the subsurface of Mars had an impact, whether that was created habitable environments in the subsurface of Mars, and understanding how fluids interacted with the rocks and how they changed the rocks over time. And that tells us a lot about the environment and how the surface of Mars has evolved through time.
All right. Thank you so much, Katie, for answering so many questions. With this, I think I'm going to go ahead and hand it back to you, Marina, and thank you both. This has been so fun to be able to bring so many questions to you. And as we navigate the new normal, if you can call it that, of live streaming and dealing with all of our technical issues of connecting from our homes, but we can still be alone together. Right, Marina?
That's right, Stephanie. Thank you so much to the audience who participated. Those were amazing questions. I know everyone is really excited. Thank you so much, Stephanie. And thank you so much, Katie. I know all of us are really looking forward to the science return. I know that I'm very much looking forward to weather station science return that we're going to get from that. But thank you, Katie. Thank you so much for everybody with us, joining us live today. Now, the launch window for Mars 2020 opens on July 17th and will land on the red planet on February 18th in 2021. And for the latest on the Mars 2020 mission, follow NASA Persevere on all social media platforms. And you can watch all of the behind the spacecraft video profiles on the NASA 360 YouTube channel. Now we're going to be doing Q&As with Mars 2020 team members each Thursday, right at the same time at 1 p.m. Pacific and 4 p.m. Eastern for the next few weeks. So make sure to tune in. As we all navigate through this time together, make sure to check out NASA at Home as we continue to explore. Until then, stay safe.